First of all, we understand the concept of degree of freedom. So degree of freedom is defined as the motion possibilities in different directions. Or in other words, the second definition is the number of independent coordinate to specify or ascertain the position of a rigid body in space is called as degree of freedom. So here we are in this figure, we are considering a rigid body. Rigid body means a body which shows negligible deformation under load is called as rigid body. This rigid body can move along x-axis. This rigid body can move along y-axis. This rigid body can move along z-axis. So it is having three translatory degree of freedom. This rigid body can also have rotation about x-axis, have rotation about y-axis, have rotation about z-axis. So it is having three rotational degree of freedom. So in total, this body is having 6 degree of freedom, 3 translatory along x, y and z direction and 3 rotational about x, y and z axis. So the formula to find out the degree of freedom is 6 minus number of restraints. Number of restraint means if we restrict the motion of this body in certain direction, we can have restriction on translatory motion, we can have the restriction on rotational motion. So we are putting that term here, and whatever is the remaining digit on the right hand side, that to that we are calling as a degree of freedom. Instead of a space body, if we have a body in plane, suppose we have a body in x and z plane, so that body can move along x-axis, that body can move along z-axis, and that body can also have rotation about the y-axis. So if we are talking about a plane body that is having 3 degree of freedom, one along x-axis, second along z-axis, and third along the rotation about the y-axis. So the formula to find out the degree of freedom for a planar body is 3 minus number of restraints. So we take some examples with the help of which we try to explain the concept of means how to count the number of restraints and how to find out the degree of freedom of a kinematic pair. Here we see the different combinations of kinematic linkage and see how to find out the degree of freedom and how to count the number of restraints. So the first combination is a sphere plane combination. So we are placing a sphere on a plane surface, and this is the axis of x, this is the axis of y, and this is the axis of z. So if we see this sphere and see the possible motion of this sphere can move along the x-axis, this sphere can move along the y-axis, this sphere cannot move freely along the z-axis. So it is having one restriction along the z direction. If we see the rotational motion, so this sphere can rotate about the x-axis, about the y-axis and about the z-axis. So it is not having any restriction along the rotational direction. Only one restriction it is having, that is along the z direction. Okay, and that is on the translatory motion. So we see that the restriction is 1 here and the degree of freedom is 6 minus 1, that is 5. And a pair which is having 5 degree of freedom, we are calling that pair as a P5 pair, means that pair having one restriction. That pair we see and we are calling that pair as P5 pair. In the second figure we have a cylinder plane combination, means we are putting a cylinder on a plane surface. If we see that cylinder, the possible motion of the cylinder, it can move along the x direction, it can move along the y direction, it cannot move along the z direction. It is having one restriction, means translatory restriction along the z direction. If we see the rotational motion, so this cylinder cannot rotate about the x-axis, it freely rotate about the y-axis and about the z-axis. So it is having one rotational restriction, that is along the x-axis. So it is having two restriction in total. So the degree of freedom is 6 minus 2, that is should be equal to 4. Basically it is called a P4 kind of pair. In the third figure we have a prism on plane. We have a prism and that prism is placed on a plane surface, and this is the axis of x, y and z system. If we see the motion of this prism, it can move along the x direction, it can move along the y direction, it cannot move along the z direction. So it is having one translatory restriction along the z direction. And if we see the rotational degree of freedom or rotational motion, so this body cannot rotate about the x-axis, this body cannot rotate about the y-axis, but it can rotate about the z-axis. So it is having in total three restriction. 1 along the z direction, that is translatory restriction, and 2 along the rotational direction about x and about y axis. So it is having 3 restrictions. So degree of freedom is 6 minus 3, that should be equal to 3. This kind of pair we are calling as a P3 pair, which is having 3 degree of freedom and having the 3 restrictions. Next combination we have sphere cylinder combination. If we have a cylinder and inside the cylinder one sphere is placed. So if we see that this sphere cannot move along the x-axis, it can freely move along the y-axis, and it cannot move along the z-axis. So it is having two translatory restriction, one along the x-axis and second along the z-axis. If we are talking about the rotational motion of this sphere, it can rotate about the x-axis, it can have rotation about the y-axis, it can have the rotation about the z-axis. So it is having no restriction along the rotational direction. So total, if we see that total restriction, it is having 2, and that is along the translatory direction. So it is having degree of freedom as 6 minus 2 is equal to 4. It is called as P4 pair. In the second, we have a sphere slotted cylinder combination. So if we have a same combination as we have taken the first one, but here the cylinder is slotted. So we are making a slot inside that cylinder, and we are fixing a linkage, okay, with the sphere. So if we see that now it cannot move along the x-axis, it can move along the y-axis, but having certain restriction. Okay, up to the width of this slot, it can move along the y direction, but it can move. So it is having motion along the y direction. Now if we are talking about the z direction, it cannot move along the z direction. So it is having two translatory restriction, one along the x direction, along second along the z direction. If we are talking about the rotational motion, it can rotate about the x-axis, but because of this slot, this body, and because this linkage which is combined with the sphere, this sphere cannot rotate about the y-axis. So it is having one restriction along the rotational direction. If we see about the z direction, it can freely rotate about the z-axis. So it is having total 3 restriction, 1, 2 in the transit direction and 1 along the rotational direction. So it is having degree of freedom as 6 minus 3, that should be equal to 3, and this is called a P3 pair. In the next, if we have a cylinder, we have the two concentric cylinders. One is the bigger cylinder, and inside this we have a smaller cylinder. So here if we see that the cylinder cannot move along the inside cylinder cannot move along the x direction, it cannot move along the z direction. So it is having two restrictions. It can freely move along the y direction. Okay, so it is having two translatory restriction, one along the x direction and second is along the z direction. If we are talking about the rotational, it cannot have rotational motion about the x-axis and about the z-axis, but it can have the rotational about the y-axis. So it is having two translated restriction and two rotational restrictions. So total restriction is 4 here. So degree of freedom is 6 minus 4 is equal to 2. So it is called a P2 kind of pair. It is the pair which is having 2 degree of freedom and having 4 restrictions. In the third one, if we are providing a colored cylinder, in the same as in figure 3, but if we are providing some color, color means we are restricting the motion along the y direction also. So now it is having restriction along the x-axis, along the y-axis and along the z-axis. So it is having three translatory restriction, one along the x direction, second along the y direction and third along the z direction. If we are talking about the rotational, this body cannot rotate about the x-axis, about the z-axis, but it can rotate about the y-axis. Okay. So it is having 5 restriction, 3 along the transit direction x, z and y direction and 2 along the rotational directions, means along the x direction and along the z direction. So it is having total 5 restriction. So degree of freedom is 6 minus 5 is equal to 1, and that kind of pair we are calling as a P1 pair, means the pair which is having single degree of freedom or having 5 restrictions. And next we consider the spherical combination. So we have a sphere and that sphere is fitted or moving inside a spherical cavity. The examples are car mirror or pen stand. So here, if we see the motion of this sphere, it cannot move along x direction, it cannot move along the y direction, it cannot move along the z direction. So it is having restriction in all the three directions. If we see the rotational motion, this sphere can rotate about the x-axis, it can rotate about the y-axis, and it is having rotation about the z-axis. So it can move along, or it can rotate about the x, y, and z directions. So it is having only restrictions in the three transitive directions. So it is having three restrictions. So total degree of freedom is 6 minus 3 would be equal to 3. So it is called a P3 kind of pair. In the next one, if we are making some slot in the spherical uh, assembly, so if you see the motion of this body, now it is having translatory restriction along x, y, and z direction. Now if we are making a slot and if we are fixing a linkage with this sphere, so if we see the rotational degree of freedom, so it can, this sphere can now rotate about the y-axis and it can rotate about the z-axis, but this sphere now cannot rotate about the x-axis because we are making a cavity and we are fixing a linkage. So because of this linkage, it cannot move along the x direction. So we are putting one additional restriction on the rotational degree of freedom along the x-axis, and it is already having three restriction in the transitive direction. So total it is having four restriction. So degree of freedom is 6 minus 4 should be equal to 2. So it is called a P2 pair, means the pair which is having 2 degree of freedom having 4 restrictions. Next we have a prismatic combination. We have a block, and inside this block a cuboid block is moving, and if we see the possible kind of motion of this inside block, so it can move along the x direction, it cannot move along the y direction, it cannot move along the z direction. So it is having restriction in the two transit direction, one along the y and along the z direction. And this, if we see this block, because if we see the cross section, it is of rectangles shape cross section, so it is having restriction in all the rotational direction along x, y, and z directions. So total, if we are talking, it is having 5 restriction, 2 translatory and 3 rotational. So it is having total degree of freedom as 6 minus 5 should be equal to 1. This we are calling as a P1 kind of pair, means the pair which is having single degree of freedom and which is having 5 restrictions. Come to the formula to find out the degree of freedom for a mechanism. So first of all, we understand the concept of the mechanism. We understand the concept of the linkage. If the two linkages are joined together, we are calling them as a kinematic pair. If similar type of kinematic pairs we join and the last link is joined with the first link, so that we are calling as a kinematic chain. In that kinematic chain, if we fix one link, so that we are calling as a mechanism. Means the thing is, if we are fixing one link in a kinematic chain, that we are calling as a mechanism. So if we see the total mobility or total degree of freedom of a space mechanism, so we can derive a generalized formula with the help of which we can find out, for any space mechanism we can find out the degree of freedom, and that formula is degree of freedom should be equal to 6 into n minus 1 minus 5p1 minus 4p2 minus 3p3 minus 2p4 and minus 1p5 or p5. So this is the general formula to find out the degree of freedom of a space mechanism, because we are calling it as a mechanism where m is the number of total linkages in a mechanism, p1 is the number of pair having single degree of freedom, number of pair having 2 degree of freedom, number of pair having 3 degree of freedom, number of pair having 4 degree of freedom, number of pair having 5 degree of freedom. The concept of P1, P2, P3 and P4 and P5 we see in the previous slides, how we are finding out these values and how we recognize these P1, P2, P3, P4 and P5 pair. Now, because we are talking about the mechanism, so if the total number of linkages are n, so there are n minus 1 linkages which can move. and each link having 6 degree of freedom. So total degree of freedom of this space mechanism is 6 into n minus 1. Here all the other terms are called the restriction into the different directions. So here P1, P2, P3 and P4 and P5 we are counting out the number of pairs of P1 kind, P2 kind, P3 kind and P4 and P5 kind, and we put the value here, and this way we can find out the degree of freedom for a space mechanism. We are multiplying this P1 with a digit 5 because P1 is the number of pair having single degree of freedom, means it is having 5 restrictions. That's why we are putting here minus 5P1. Similarly, if we are talking about the P2, so P2 pair means having 2 degree of freedom, means it is having 4. So we are putting a 4 here, 4 restrictions we are putting in. We are putting a 4 digit here. Similarly, P3 having 3 restrictions. Similarly, P4 having 2 restrictions. Similarly, P5 means the pair having 5 degree of freedom, which is having only 1 restriction. That's why we are putting here 1 digit here. And we subtract all these restrictions with 6 n minus 1 and find out the degree of freedom for a space mechanism. If we are talking about the planar mechanism, as we have discussed that we have a body which is placed in plane, it can move along the two translatory axes and having rotational about the third axis, so it is having total 3 degree of freedom. So a general formula to find out the degree of freedom for a planar mechanism is, that is, degree of freedom should be equal to 3 into n minus 1 minus 2p1 minus 1p2. As we see that there are total n number of linkage in a plane mechanism also. So total number of linkages are n minus 1 because we are talking about the mechanism, and each linkage is having 3 rotational degree of freedom. So the total degree of freedom is 3 into n minus 1. The other terms which are with minus sign, these are the restrictions. So minus 2p1 and minus 1p2 means p1 means pair having single degree of freedom, that is having 2 restrictions because total degree of freedom is 3. Similarly, minus 1p2 means pair, P2 pair means having 2 degree of freedom, means having 1 restriction. So the formula to find out the degree of freedom for a planar mechanism is, that is 3 into n minus 1 minus 2p1 minus 1p2. So with this formula we can find out the degree of freedom for a space mechanism as well as for the planar mechanism. So first of all, we understand the concept of redundant linkage. So here with these two figures we try to explain the concept of the redundant linkage. So redundant link, the definition is, if we remove that link from the mechanism, it does not affect the motion. Okay. So that link we are calling as a redundant link. In the first figure, if we see, there are total 5 linkages, and it is a planar mechanism because one link is fixed. Okay. So the total degree of freedom for the planar mechanism is 3 n minus 1 minus 2p1 minus 1p2. So we have to count the number of p1 pair and number of p2 pair. P1 means the pair which is having single degree of freedom. So if we see all the connection and all the joints between the different linkages are turning pair, okay, or they have the pin joint. So if they have the pin joint, so all will count into the P1 pair. Yeah, there is no P2 pair because P2 pair having 2 degree of freedom, so there is no such combination or there is no such connection between the different linkages which is having P2 pair. So P2 pair is 0 in this example. So here all are the P1 pair. If we count them, so this P1 pair is coming out to be 6. Number of linkages here is 5. So we apply the formula 3 into 5 minus 1 minus 2 into 6 minus 2 into 0 because there is no P2 pair. So 12 minus 12 total 0. So the degree of freedom of this first figure is 0. And that normally we call that as a structure. Means it does not have any movability basically. This is the meaning of this one. If we come to the second figure, so in the second figure, if we adjust the length of the link 4 and put this length of the link 4 equal to 2 and 5, okay, and if we do the orientation of the link 4 in such a way that it is having parallel to the 2, 4 and 5. So if we see that here, if we, any of the link either 2, 4 and 5 we remove, it does not have any difference in the motion. Means any link, if we remove 2 link, if we remove 4 link, if we remove 5 link, so the motion of the whole assembly will remain as it is uh, in the starting basically. So These links we are calling as a redundant link, means 2, 4, 5 are called a redundant link. Any one link we can remove from here basically. So if we remove any one link, so the degree of freedom is 3 into n minus 1 minus 2p1 minus 1p2. Now there is no p2 pair because all again the turning pair having single degree of freedom. But now if we remove any of the links, suppose 4 link we remove from this second figure. Now we have the total number of linkages as 4 in this case now, that is 3 into 4 minus 1. The n is 4 here. Then 2p1, the p1 pair is again 4 if we count them. And there is no p2 pair. So total is 9 minus 8, that come out to be 1. Now this link, the second linkage is we are having degree of freedom as 1. And this is called the double parallelogram kind of linkages. And here we understand that the concept of the redundant linkages means any of the link either 2, 4, 5 we remove from the mechanism does not have any effect on the motion of this mechanism. Understand the concept of redundant degree of freedom. So with this example we try to understand this. In this example we have the 4 linkages. Link number 1, link number 4 is a binary link, link number 3 is a and 2 is a kind of cam pair, and 1 2 having a pin joint here. Then similarly 4 and 1 is having a pin joint here, 3 and 4 is having a pin joint here. If we are talking about the combination of 2 and 3, so they are the cam pair, so they form a higher pair because they have the 2 degree of freedom. Now what is redundant degree of freedom in this case here? If we rotate the link 3, it will not cause the motion to any other of the linkage of this mechanism. So when such type of uh, situation is there in any of the kinematic mechanism, that they will introduce a additional terms into the formula to find out degree of freedom, and that is called the redundant degree of freedom. That is the formula now is modified, that is 3 into n minus 1 minus 2p1 minus 1p2 minus FDR, where FDR is the redundant degree of freedom pair basically. So here if we see that in this n is 4 here, so this is 3 into n minus 1 minus 2p1. If we are talking about the p1 pair means turning pair, so 1 and 4 is having a turning pair, 3 and 4 is having a turning pair, then 1 and 2 is having a turning pair. So there are total 3 turning pair, means p1 kind of pair which is having single degree of freedom is 3. 2 and 3, if we see the combination, because they are the cam follower, so they have the p2 kind of pair which is having 2 degree of freedom. So this is p1 is equal to 1 in this case. FDR means redundant degree of freedom is having 1. Means if we rotate the link number 3, so it will not cause any other part of the linkages to starts moving. So it is FDR should be equal to 1 in this case here. So total degree of freedom is coming out to be 1 for this kind of mechanism. So with this we understand the concept of redundant degree of freedom and how we modify the formula of degree of freedom. Now in some situation there are spring in the different mechanism. So as we see that because linkages, some force is applying on the linkages, so there should be a elongation and compression of the linkages. A similar type of combination we have in the spring also. Spring can be elongate and it can be compressed. So the spring can be replaced with the linkages. So here if we see that this is a mechanism which is having 1, 2, 3, 4, 5 and 6. Suppose 6 linkages are there. 4, 5 is a single link. So we can count that total linkages there are 5. But this spring is there. So first of all spring we have to replace. So spring is replaced by 2 binary links. So here if there should be a spring, so we replace it first. So the other part of the mechanism remain as it is, only this spring we remove from here and replace by the 2 binary links, okay, having pin joint between 4 and 5. So now we can find the degree of freedom of this mechanism. So first of all we have to replace this spring with the equivalent number of binary linkages, 2 binary linkages, and then we have to find out the degree of freedom. So here we understand the concept of replacement of cam pair. This cam pair which is having 2 degree of freedom, this can be replaced with 1 binary link having 2 turning pair. Now how to replace it? Now here in this first figure we see that 1 and 3, these two linkages forming a cam pair because they are having some curvature. So to these kind of pairs which is having some curvature and having some point of contact, so these we are calling in kinematics as cam pairs. And the 1 and 3 are forming a cam pair, and to replace it with a one binary link having two turning pairs, we have to find out the point of contact. So point of contact is x here. With respect to that point of contact, we are finding out the center of curvature of the upper link 3 as C, and we are finding out the center of curvature of the lower link as D basically. Although it is having different center of curvature or different curvature at different points, but with respect to the point of contact x we have to identify. So with respect to that point of contact x, it is having C center of curvature for the link number 3 and having D center of curvature with respect to the for link number 1 with respect to the point of contact x. Now we join this C to D including x. So this way we can replace this both cam pair with a binary link, that is uh, link CD, and with two turning pair means C and D we have the two turning pair. This way we have to do. In the second also we are doing the same kind of thing. We have the again the cam pair because they are having some curvature and having some point of contact. So this x is the point of contact. With respect to that point of contact, we have to identify the center of curvature for the upper linkages, and that is B. B is the center of curvature for the upper link, and for the lower link if we see this A is the center of curvature with respect to that point of contact x. Although it is having varies curvature at different points, but with respect to that x point of contact we have to identify. So B and A are the point of curvature. So we have to join B with A including x. So we join B with A including x. This way we have these two cam pair again can be replaced with a one binary link having two turning pair at point B and A. Now the second thing is, if we are replacing this with one binary link with two turning pair, now we have to make a kinematic change. So now we can join this C point with B by the binary link. Similarly here also this BA link which we are getting after replacing the cam pair which is having 2 degree of freedom. Now this point A is having a turning joint, and this also have to combine with this point O center of curvature of the center of rotation of this link lower link basically. So this we have to join with the help of the binary link. Yeah, so this way we have to replace the cam pair with the one binary link having two turning pairs. In this video we understand the concept of degree of freedom and see the different formula for space mechanism as well as for planar mechanism of degree of freedom. Means how to find out the degree of freedom. We understand the concept of redundant linkages. We understand the concept of redundant degree of freedom and how the formula for planar mechanism is modified. How to count the P1 pair, the pair having single degree of freedom. How to count the P2 pair having 2 degree of freedom, and how to replace a cam pair with the help of a binary linkage having two turning joints, and also how to replace the springs with the help of two binary linkages with a pin joint. So if you understand this video completely, so please like, subscribe and share this video. Thank you very much.